Hi there, this is PF6, the end behavior of polynomial functions. We are getting there. We are making progress, everybody. After this chapter, then there's just one more on sinusoidal graphing, which I think is a lot of fun. Okay, so polynomial functions. So the whole chapters. We're on the 6th video. Now we're finally talking about them. Okay, polynomial functions. It's a function. So you already know that for every x, there's only one y. That contains only addition, subtraction, multiplication, and division. Just hold on. I'm making a few purple marks in here, so I need to come back and make this a little bit better. Whole number exponents and 2 variables. That's what we're going to be looking for. So there's no trig functions, there's no logarithms, fractional exponents, square roots, and none of that stuff. So here are the examples. So we've got x's and y's, and it looks like there's some exponents here. Oh, we also used f of x. And if that makes you crazy, you can always just replace it with a y. It's going to be the same. Which one of these is not like the others? One of these things just doesn't belong. I hope you picked this one. I put it in there as a little bit of a weird example because the rules that we have all work when it starts with either f of x equals or 99% of the time y equals. This question is a function, a polynomial function, but it's not in standard form. Let's put it that way. So what I want to do is I want to get this guy all by his lonesome. And then I'm going to be able to follow all the rules. Whoops. First thing I want to do is minus 4x minus 4x. So 4y is equal to 10 minus 4x. Now I need to get rid of the y. So these are side by side, they're multiplying, so divide. Now, careful. Every little bit, every single term gets divided by 4. So that cancels out. Y is equal to, you could leave it as 10 divided by 2, or you can divide that out and get 2.5. Well, it's weird. Minus, this is going to cancel out x, and that's completely fine. I don't know. That's, in my world, perfect standard form, where you've got your x before you have your constant. So ta-da, that's what I'm going to put underneath that. And y is equal to minus x plus 2.5. So remember that, because I have a habit of throwing at least one question. On every test or every assignment where you have to make it so it's y equals. Okay, so this side, what's wrong? Oh, there you go. It says fractional exponents, decimals good too. I didn't actually know how to do a fractional exponent without it being difficult. So I just went 1.6. Okay, so here we have trig functions, y is equal to sine x or cos x. This is a logarithm one. Ooh, remember in finance, we had that like one equation that you had to use logarithms for. Not polynomial functions. Here we've got a square root example. Now this one looks a lot like this one. Let's leave it up. Okay, and in fact, I'm going to show you what happens if we try and solve this one for y. So x squared plus 9y squared is equal to 81. So I'm going to minus my x squared minus my x squared. So 9y squared is equal to 81 minus x squared. Okay. Now we can divide by 9. So y squared, 81 divided by 9 is 9. Oops, it plus my squared minus x squared. I'm just going to leave it over 9. But our problem is we don't have y squared. Sorry, we don't have y. We have y squared. So to actually finish solving this, you'd have to take the square root of both sides. So y is equal to 9. Sorry, square root of 9 minus x squared over 9. No, that would be an equation with a square root in it. So no, nope, not going to do that. I'm just marking these so I can add it in later. So if somebody's looking at the answer key going, well, how did she go from there to there? These will be part of the answer key. Okay, so good. You know what it is. Or mostly, you know, if you see any of these, I'm messing with you. Don't mean to, but sometimes I do. Okay, vocabulary. Boom. Here we go. First of all, we want to, okay, it's never a bad thing. But I guess now that I'm looking at this section, you don't necessarily have to rewrite stuff and put it in descending order. But standard terms means your exponents go from highest to lowest. This is very important. Your leading term is the one with the highest exponent, and I don't care where it is in the equation. The leading coefficient is the number in front of the leading term. Include your sign. And the degree is the highest exponent in the equation, which then allows you to pick out these two, which means I probably should put that first. And the constant is there's a number and it hasn't got a variable. It's called a constant because it's worth the same thing. So like 5. Wait. So 5, it's not going to change. Whereas if I said x today, x could be 3. In the next question, x could be 15. Who knows? But 5, it's just 5. All right. This may seem weird, but be patient with yourself. It's actually pretty easy. Oh, get yourself a handy dandy highlighter. It'll make you happier. All right. So what I'm going to do is I'm going to look at my equation and I'm going to find my biggest exponent and I'm going to highlight that entire term. And you know what? I'm just going to do it on all of them. I've got an exponent 8 and 6. Okay, this is the bigger one. This is the bigger one. That one. Well, those weren't very challenging. They're almost all at the front. So my degree is my highest exponent, 2. Done. Leading coefficient, 3. Done. Constant, -5. Ignore this for now. Don't need it. So here's a question where if I wanted to put it, to write it in standard form, whoops, I would just rewrite it as y is equal to -5x plus 10. But truthfully, it really doesn't get us anywhere. It doesn't help us if you are factoring, solving equations, doing a whole bunch of other stuff. It's really important. But I realize now for this section, nah, just find the one with the biggest exponent. Which reminds me, what's the exponent on there? I hope you said there's a little bitty understood one. So 1, my leading coefficient is a -5, and my constant is 10. All right. I want you to pause the video, do the rest of the page. Okay. So it's pretty simple if you get the highlighter out and, you know, highlight the biggest one. So degree 8, leading coefficient is 3, and 13. Oh, by the way, I should have made an example like that. If that's all we had, then my coefficient, or sorry, my constant can be 0 if there's nothing there, but I forgot to make one like that. So degree 3 -3 minus 15. Degree, oh, nothing wrong with putting a 1 in there. It's going to be 1. Oh, my leading coefficient. What number can we put out in front? Yeah, understood. We're just too lazy. We don't write anything. And minus 15. And degree 2. And 5. And minus 1. All right. Hold on a sec. I don't know what's on the next page. Oh, look, more of it. I'll have to make it pretty and put like page 2. Do it. Pause the video again. I think you can do all of them. Looking if there was a sneaky one on there, but there's not. I may have to add one. Okay, hope you did that. Highest exponent. That one's a 4. There, there, there. Oh, okay, put the 1 in for you. That's a question mark. Okay, degree. 3, leading coefficient 2. Oh, here's 1. Constant 0. Because there's nothing there's no number there without a variable. So I could theoretically, right? That's where the 0 is coming from. Because if I have this, whatever value that is, and I add 0, yeah, nothing changes. So we're allowed to do that. Oh, 4. That's my biggest one. And 2 and 4. Exponent of 2. If a half makes you crazy, feel free to put 0.5 and minus 6. 3. What's my leading coefficient? Yep. 1 and minus 8. And 5 and 3. Oh, there's no constant. 0. And 1 and 7 and 12. And 2 and minus 9. Oh, hold on. Hold on. There's madness. There's a trick question, and I don't think any of my students have ever said anything about this one. Look, look, look. 18 and 15. These are just plain old numbers. So really, f of x is equal to negative 9. Ah. So sneaky, I didn't even catch it myself. Yeah, so watch that. If there's like terms that needs to be done before you find this. This really won't change our question a whole lot. Okay, like half a mark here, but when we do the analysis, it's not going to change anything. But if you had more x squareds and you didn't put them together, it would change a whole bunch of stuff, or it could. All right, not sure why I put that. Y is equal to 10. Well, there's not even an x there, right? Because the degree is the exponent. Oh, let me write that. Highest exponent on the x. So if anything, it's 0 and 0 and 0. It was, oh, wait, I guess our constant would be 10. There. Never mind, I shouldn't have put that question in. The one question I wanted to do is just something as simple as 5 minus y. You see this? Yep. Is equal to, I don't know, 15x. Okay, you need to move stuff around and solve for y before you can do this. So I want to get this by itself. I'm going to subtract 5, subtract 5. So minus y is 15x minus 5, right? I can't put those together because this has an x and this does not. And a lot of you get there, but don't forget. So y is equal to minus 15 plus 5. Oopsie, I lost my x's. So then degree is 1. My leading coefficient is minus 15. This is where your leading coefficient sign is going to be wrong, in which case your graph, whoops. Okay, never mind, I'm not going to do that because I'm looking in the camera and it's mirrored. This graph should go this way, in this direction. Whereas if you solved it here, oopsies, it should be this one. This is the right one. This is the wrong one. If you forget. No, I was right the first time. Yeah, never mind. I should stop talking. That one's good. And don't worry, because we haven't really got to that part yet. Okay, so that's just the sort of the takeaway from this part is remember it has to be y equals something before you can find the leading coefficient, the degree, and all that stuff. All right, awesome. Thanks for joining me on this mathematical adventure.